You've never seen Saturn like this before. The James Webb image we've all been waiting for has finally been released, and it shows previously unknown sides of Saturn. We may have missed something important in this planet's ring system. There have long been rumors that things are going on in the rings of the gas giant that will give us important new insights into the true processes in the universe. What new secrets will the James Webb Space Telescope reveal in Saturn's rings? The James Webb Space Telescope showed us shocking images of the early universe that turned our entire astrophysics on its head. And now the new telescope is cleaning up in our solar system. These days, we are seeing images of planets that we have never seen before. Saturn shines in Webb's pictures as if it were really another planet. One question in particular has long preoccupied scientists. What is really going on in Saturn's ring system? Until now, researchers have only had vague assumptions about this, and no one has really dared to say what is truly happening there. James Webb was now asked to take another look, and thanks to highly developed infrared technology and special filtering, it provided unprecedented insights. Never before have scientists looked so deeply into the structure of the rings and onto Saturn's surface. Thanks to this improved view, new aspects of the ring structures are now becoming visible and could solve a centuries-old mystery. Saturn is not the only planet that appears in a completely new light thanks to Webb. The Space Telescope also looked at Jupiter, Uranus, and Neptune. Would you still recognize the planets? Again, it is not a purely aesthetic effect why Webb depicts the planets in this way. Scientists have a suspicion, and the new images are said to provide evidence of previously unimaginable phenomena. Under the dense layers of dust and ice, something could be hiding that has remained undiscovered for millions of years. Life in Saturn's rings. The rumors surrounding Saturn are not new. Structures have been suspected in Saturn's rings on several occasions that point to activities beyond our previous ideas. Saturn's rings were long perceived as a single structure until images taken by probes showed that they are, in fact, many individual rings. Today, we know that the rings have completely different formation histories and presumably also very different ages. Some rings consist of dust and ice and were probably formed early in the planet's evolutionary history. Other rings were likely formed from collected pieces of rock or possibly debris from asteroids or shattered minor planets. The icy moon Enceladus has also played a notable part in ring formation. The moon spews fountains of ice and frozen water vapor up to 10 kilometers high into the surrounding area, and thus feeds one of the outer rings practically all by itself. These processes show scientists that Saturn's ring system is a cosmos in itself. The changes, the active icy moon Enceladus, and the widely varying composition of the rings appear to be a dynamic and almost living system that is formed in the area of attraction of the gas giant Saturn. In the new infrared images, the rings appear as bright, thick horizontal bands that have a snowy sheen and stand out clearly against the dark planetary background. The glow is caused by the ice and rock particles that reflect a considerable amount of infrared light in the rings. What do brown spots on Saturn's surface reveal? Saturn as a chocolate-brown sphere with a brightly glowing ring looks really different. Infrared filtering has a special purpose here. 2. This is the only way to make processes from the interior of the gas giant visible, and we urgently need to know more about the processes inside the planet. Perhaps there is evidence of a surface and a climate in the depths of Saturn's atmosphere. When the Cassini space probe photographed Saturn and inspected the North Pole, it revealed something incredible. Traces of meteorological phenomena were visible in the depths of the center of the storm, which is shaped exactly like a hexagon. Some scientists said that the image looked as if a blue sky was shining in the depths of Saturn. This is really hard to imagine, but we don't know what the gas giant looks like inside. We only ever see the surface of gas and clouds. It's similar with Venus, where we only see the dense atmosphere that completely envelops the interior. We know that Venus is a rocky planet, and this was proven by fascinating images taken by probes in the 1970s. Although calculations have shown that planets like Saturn and Jupiter are most likely only made of gas in their interiors, we could be wrong, and there may be something like a solar core after all. This final image was taken after a 20-hour exposure of the gas giant. Webb then combined several raw images taken with different infrared filters into a single image. The new image of Saturn shows the planet as a dark circle in warm orange and brown tones. This image differs considerably from the well-known Hubble Space Telescope images, which often show Saturn with bright bands of clouds. The reason for this different appearance is that Hubble was only able to capture and image light in the visible wavelengths. Thanks to the new image, Scientists now see the upper layers of Saturn's atmosphere in a completely different way, and they want to use these images to finally get to the bottom of methane absorption in Saturn's environment. A circumstance comes to the rescue here because infrared light of a certain wavelength is almost completely absorbed by the methane gas in Saturn's atmosphere, making the planet dark in the image and allowing researchers to recognize the exact distribution and density of the methane gas in the dark areas. Two dark spots stand out in particular. The concentration of the gas appears to be particularly high here, which in turn tells the researchers more about the processes in the deeper layers of the planet. Methane is the third most common gas in Saturn's atmosphere after hydrogen and helium. The atmosphere at the edge of the planet's disk glows brightly, possibly caused by methane fluorescence or emissions of trihydrogen ions. The image was taken near the end of the 7-year summer in the planet's northern hemisphere. Seasons on Saturn last so long because the planet takes about 29.5 Earth years to orbit the Sun once. This long orbital period means that each season on Saturn lasts more than 7 Earth years, resulting in extreme and long-lasting climatic changes on the planet. During these long summer and winter periods, temperature and weather conditions can change drastically, resulting in phenomena such as strong storms and unusual atmospheric conditions. These extreme seasons also contribute to the formation and alteration of methane and aerosol structures in the atmosphere, which can now be accurately observed for the first time by telescopes such as a JWST. The images therefore help us to precisely study Saturn's meteorological processes and its seasonal changes. The processes on the surface and in the uppermost layers promise us new insights into the deeper layers. And hey, we could be in for some surprises. Webb also photographed Saturn's moons. Who would have thought that Saturn's moons would also appear in a new light in the new images? Webb was able to capture 3 of Saturn's 145 moons, Dione, Enceladus, and Tessis, which can be seen in the image. Enceladus, in particular, is fascinating as it ejects fountains of water almost 10 kilometers high from a subterranean ocean into space. Phosphorus was recently discovered there, making Enceladus a promising candidate for the search for extraterrestrial life. Enceladus is a rather small moon with a diameter of around 504 kilometers. It is much smaller than Saturn's moon Titan, which has a diameter of 5,150 kilometers, or Jupiter's moon Europa, which has a diameter of around 3,121 kilometers. Nevertheless, there are many moons around Saturn that are much smaller than Enceladus. Some measure only a few hundred meters in diameter. If there really were life on Enceladus, the size of the potential habitat would be roughly comparable to the area of the German state of Lower Saxony. Dione and Tessis are also medium-sized moons of Saturn. The former has a diameter of around 1,122 kilometers, which makes it slightly larger than Enceladus. The latter, on the other hand, has a diameter of about 1,066 kilometers, making it slightly smaller than Dione but still larger than Enceladus. Both moons are known for their icy surfaces and interesting geological features, making them fascinating objects of exploration. Several of NASA's upcoming missions will fly to these promising and as yet largely unknown celestial bodies. Webb lights up Uranus, Neptune, and Jupiter. It seems almost unbelievable how different old acquaintances such as Uranus, Neptune, and Jupiter look in the filters of the James Webb Space Telescope. Anyone who doesn't know which planets are visible here would think that Webb has taken pictures of bizarre and beautifully luminous alien star system. By highlighting the rings and certain gases, none of these planets look the same as we know them from numerous other images. For a moment, it's almost disappointing that these beautifully luminous worlds don't exist somewhere in the universe. Webb has photographed the planets in different light frequencies to reveal new details and secrets of these planets. The new appearance alone shows how little we really know about these planets and how much there is still to discover. The rings of Uranus and Neptune are so delicate that they are barely visible with other telescopes. And here, Uranus's rings shine brightly. You don't have to be a professional astronomer to realize that Webb's filters offer unique opportunities to examine these ring systems more closely for the first time. The highlight of this filtering is not just the light or the extraordinary beauty of these images. Webb can create more precise analyses from the light rays over each individual element imaged. This telescope reads light like no other before it. Minimal radiation is enough to determine the composition of gases and the presence of certain elements. Uranus reveals not only the fascinating ring system in infrared light, but also completely new views of the atmosphere and the dynamic processes of the planet. Infrared light easily penetrates through dense atmospheres and cloud layers, revealing deeper structures for the first time. The images reveal complex atmospheric patterns that would never be recognizable in visible light. For the first time, active weather observations are now possible on a planet that is millions of kilometers away from us. Neptune also shows us many more details of its stormy atmosphere in infrared light, and we can see the planet's faint rings and its moon Triton with impressive clarity for the first time. Jupiter shows us a detailed structure of its atmosphere and its gigantic storms in different light frequencies. The infrared images show the Great Red Spot in a new level of detail. Researchers can see the vertical structures in the images and determine temperature differences within the red spot and the neighboring regions. In this way, Jupiter's weather can now be easily observed. And this information also gives us more insight into what is going on inside the largest planet in the solar system. Subscribe now and be part of every new video highlight.